Hi everyone, we're still on exercise 2C, looking at some of the harder examples. This is on page 31. A cyclist A and B lead the same spot from rest and travel in opposite directions. Cyclist A accelerates at 0.5 meters per second. Cyclist B accelerates at 1 meter per second. How far apart will they be after 10 seconds? This is another example of what's useful is using their relative accelerations rather than their actual accelerations. So if I was to say freeze cyclist A and say how fast is cyclist B moving away, well, they started with the same initial velocity of 0. A perceives B to be moving at 1.5 meters per second away from him. So U will be 0. V, you don't know. The acceleration is 1.5 meters per second squared. Okay, and the distance then is the distance between the two of them. So how far apart will they be when time is 10 seconds? Well, that's just S equals UT plus a half AT squared. So that's going to be 0 times 10 plus a half of the acceleration is 1.5 times 10 squared. And what's that give us? A half of 100 is 50 times 1.5 is 75 meters. After how long more will they be 108 meters apart? Again, this relative approach is going to give you a much easier run on this question than trying to treat them separately. So if the distance is 108, what's the time? So you use S equals UT plus a half of AT squared, where T is an unknown now. It's not 10 seconds anymore because this is later on in the run. So what you get there, well, that's 3 over 4. You get 108. A half of 3 over 4 is 3 over 8t squared, or whatever way you might do this algebra yourself. 108, you're going to multiply by 8 divided by 3. So 108 divided by 3 and multiplied by 8 equals t squared. Okay, that's divided by 8, so it becomes multiplied by 8. That's multiplied by 3, it becomes divided by 3. Excuse me, a mistake back there. 1.5 is 3 over 2, not 3 over 4. So dividing half of 3 over 2 is 3 over 4. So you should be multiplying by 4 here. Sorry about that. That is going to get you 144 for t squared, which means t is 12, the square root of 144. But it's 2 seconds later. The question was after how much longer, or how long more will they be 108 meters apart? Okay, question 20, another one. So a car P starts from a point O with an initial speed of 8 meters per second and then travels with a uniform acceleration of 4 meters per second squared. 2 seconds later, second car Q starts from O with initial velocity 30, moves the uniform acceleration 3 meters per second. Show that after passing P, Q will never be ahead by more than 74 meters. Now, what this question is a maximum separation question, okay? And we have a condition for maximum separation that I'm going to talk about in just a second. You've got this one leaving P, passing the point O, car P passes the point O, with an initial velocity 8, acceleration of 4. The time elapsed is t seconds. Okay. This one Q, initial velocity of 30, acceleration 3. This hasn't left until 2 seconds after this one. So if this had been traveling for 10 seconds, this one has only been traveling for 8 seconds. So the time elapsed here is same t, but you take away 2. Okay. Our condition for maximum separation, if you look here, this one is moving faster, so it is going to overtake. But this one is accelerating more. So ultimately, this one's going to end up traveling faster. So it's going to catch back up again. Our condition for maximum separation is, well, this one is moving faster. This one will start to catch up. P will start to catch Q when they have the same velocity. Okay, so as soon as this one, which is going faster, this one's going to slowly be catching up. Its velocity is going to be catching up. When they have the same velocity now, that's the biggest gap. Maximum separation means V1 equals V2, and the two cars at the same velocity. For all points after that, P is going to be moving faster because it's accelerating more. So when the question says find the maximum distance between them or show the maximum distance, will never be ahead by more than 74. The maximum distance is 74 meters. They're saying use this condition that the two velocities will have to be the same. So the velocity for P has to equal the velocity for Q. By the way, write that on the inside of your copybook. That's a very regular condition. It's one that you'll need to know. Learn it off by heart, okay? The velocity for P, V equals U plus AT is what we're going to use. So V equals U plus AT is 8 plus 4T. And down here, it's going to be 30 plus 3T. Okay. 3T minus 2. That's 30 plus 3T minus 6. So it's 24 plus 3T. So when these two velocities are equal, you get 8 plus 4T equals 24 plus 3T. Okay, let's move this to the left, move this to the right. You get 4T minus 3T equals 24 minus 8. That gives us T equals 16 seconds. So after 16 seconds, they have the same velocity, which means P is going to start catching Q again. The question has to show that they will never be ahead by more than 74 meters. So what you want to say here is, well, what's the distance of P when T is 16 seconds? Because that's when they start to catch on each other. And then what's the distance of Q? And hopefully the difference between them will be 74 meters. So distance for P, remember, S equals UT plus a half AT squared. And our initial velocity for P was 8. So that is 8 times 16, the time, plus a half of our acceleration was 4 times 16 squared. For Q, our initial velocity was 30 times UT plus a half of, its acceleration was 3 times T squared. Excuse me, as I was doing the calculations there, I realized it was a mistake. So P has traveled 640 meters. Q has not spent 16 seconds traveling. Okay, remember, it's only spent 2 seconds less, so it's only spent 14 seconds traveling. Apologies for that. So when you do the calculations on Q, it's actually 30 times 14 plus a half of 3 times 14 squared gives 714 meters. And then 714 take away 640 is the 74 meters, is the biggest possible gap we can see between these two cars. So I'll ask you now to do on page 32, question 19, please, which is a maximum separation question. You'll need this condition again. All right, talk to you in class.